Hi guys. So when verifying trig equations, as you see in this problem here, um, there are times when you're going to have to add fractions, and since we can't exactly type it in the calculator like we used to because they're not numerical values, we have to actually apply adding fractions. Now, some of you use common denominator, which is perfectly fine. But I'm going to show you another method to adding the fractions, which I also went over in the video titled Operations with Fractions. I believe I put that under Module 2. So go ahead and review that if you'd like. So before we start, notice when you verify, they already tell you the answer. So on the right side of this equal sign is the answer. We know what we have to make it to become on the left. Please don't move anything from the left to the right side of the equal sign because then you're not verifying. You're just automatically assuming it's true. So I'm only going to work on the left side of the equal sign. And mind you, I picked a more difficult problem just so I could go over all of the algebra. They won't all be like this. But before I even start adding the two fractions, I am going to put anything with a plus or minus within the fraction in parentheses because it's an expression. And anytime I substitute, add, subtract any expression meaning something with a plus or minus, it should be in parentheses. So to add the fractions, I'm going to do what's called crisscross applesauce. So it's a cross multiplication method, always left and down first. So tangent times tangent is tangent squared. There's a plus between the two fractions. So from there, I'm going to put plus. And then this is now crisscross. So I'm multiplying these two, but notice again, they're in parentheses. I'm not actually going to worry about multiplying them just yet. I'm just going to set it up. So adding and subtracting fractions, you can always use this method called crisscross applesauce. And again, it is a cross multiplication method. So whatever you're crisscross applesaucing should be multiplication. So crisscross over applesauce. Tangent times, again in parentheses, 1 plus secant. So now I can actually start the algebra. Mind you, everything is in terms of tangent and secant, so I'm going to leave it that way for now, and I'm going to work on the algebra. So always work on simplifying the numerator first. Just because if you can factor something out, you can divide it out. So it's nice to leave the denominator in factored form in case that happens. So I'm going to bring down the numerator, tangent squared x plus, and I'm going to FOIL or distribute the two binomials here, which sidebar 1 plus secant times 1 plus secant. So FOIL or distribute, I prefer foiling. You have 1 plus secant plus secant plus secant squared, which after combining the two like terms, outer and inner, it will give you 1 plus 2 secant plus secant squared. So all I did in the line beforehand was just add these two together. The secant plus secant would give me 2 secant. Over, I'm just going to keep bringing the denominator down, which will be tangent times 1 plus secant. Now, if you look in the numerator again, we're working on just simplifying the numerator as much as we can. Ideally, we'd like everything to be the same trig function in the numerator, which I can make that happen here because this is a Pythagorean identity. And under the Pythagorean identity, it states that 1 plus tangent squared is equal to secant squared. So I am going to rewrite this numerator and change the tangent squared plus 1 into secant squared. Everything else I'm just going to bring down. And I am writing every single step, so in case you're following along, hopefully you won't get lost anywhere. So I'm not done simplifying the numerator yet, and that is the general idea, is that I want to simplify the numerator as much as I can. So here I have secant squared plus secant squared, two like terms, which would give me 2 secant squared. And everything else I'm going to again bring over. Now, keep in mind this general rule of why I haven't done anything to the denominator yet. Because if you can factor something out, you can divide it out. So if you look in the numerator, you do have a GCF here. The GCF would be 2 secant. So since I'm out of room, I'm going to flip to the next slide. But keep in mind that the GCF in the numerator would be 2 secant. So from here, we're going to factor out the GCF. So that would give me 2 secant x. Factoring it out of each one of those terms, it would leave the first term with just secant x, and it would leave the second term with just plus 1. If you distribute, it should bring you right back to the last line we had in the page beforehand. And I'm just going to bring down the denominator. Again, I haven't done anything with the denominator except to bring it down. Now, if you look, if you can factor it out, you can divide it out. Factoring means it's in parentheses. You have secant plus 1 and then 1 plus secant, which are basically the same thing. 1 plus 2 and 2 plus 1 mean the same thing. Adding, it doesn't matter the order. So if I can factor it out, I can divide it out. All I'm left with now is 2 secant over tangent. Ideally, we want them to be the same trig function, but the only thing these two have in common is under the Pythagorean identity. So since they're not squared and they're not being added, that's out. Your second go-to is to always change everything in terms of sine and cosine. So in the reciprocal identity, I'm going to change secant into 1 over cosine. And for the denominator, if you look under the quotient identity, tangent is equal to sine over cosine. So from here, I'm just going to take care of that numerator. 2 times 1 over cosine would just be 2 over cosine. And the denominator I'm going to bring over. And in that same review video I talked about with operations with fractions, we don't divide fractions. We do what's called keep, change, flip. So 2 over cosine, I'm going to keep it. I'm going to change this to multiplication, and I'm going to flip the second fraction. So sine over cosine becomes cosine over sine. I can cross reduce here. I have a cosine on each one. So that divides out, leaving me with 2 over sine. So I'm going to bring this down here, 2 over sine. Now, we never leave trig functions in the denominator for the reciprocal identities alone, because we can take care of them. So I'm just going to give you kind of like an algebra point of view here. 2 over sine, can we all agree, means the same thing as 2 times 1 over sine. If I multiply it straight across, mind you, fraction form of 2 is 2 over 1. If I multiply it straight across, I would still get 2 over sine. However, this gives me a better view of what I can do now, which means I can bring down the 2, and from the reciprocal identities, 1 over sine equals 2 cosecant, which, if you look at the original problem, is what we were verifying it to become, so it does work. So again, this is one of the longer problems, but we went through a lot of the algebra, so I hope all of this helps.